Okay, I mean, I have no idea what I'm supposed. Let's see. It's okay. I think I know what I'm gonna do. How about we switch this from, instead of showing that, well, hold on. Cancel, add source. Oh wait. Bro. Bro, if someone's gonna come online and just find this random dude just trying to figure out this OBS studio thing. Can I not change like the source on this? Like if I click this, right? Like, shouldn't I be able to? Let's see. Well, properties, no. You know, I'm just gonna remove this. Delete. Yes. And then we're gonna add source. We're going to browser. Oh, hold on, that's new. Okay. A web page from the internet. Oh, okay. Wait. Okay. Hold on. Let's see. We've been given a custom CSS. That's crazy. All right. No. All right, cancel. We don't want this. Wait. Why is the browser? No, we don't want you. Yes, get out. Firefox. All right. Window, Mozilla, share. Amazing. Nice. Okay. All right. Let's go. All right. I don't know. We're supposed to study something. Let's see. We're supposed to study something. Like, look, I'm not even in the mood, but I'm trying to force myself. Like, I'm thinking maybe we should do some peptide synthesis. You know, like go over the methods. try to explain the whole process to herself again to make sure we understand it. Something like that. Bro, do I really want to do this, bro? I mean, whatever. Let's go to Firefox. I think you know what? I'm just gonna lazy around first, and I'm gonna find something to do on GitHub. So I'm gonna find something to do later. Let's see. All right. Passionate biochemist, software developer, hoping to make meaningful contributions to society. Low key, this is kind of, well, I mean, passionate biochemist, software developer. Period. What do you mean hopeful? We're getting this PhD, bro. We are. In my free time, I like watching DaVinci Resolve tutorials. That is true. Working on personal projects and reading The Revenge of the Tipping Point. Awesome book so far. Okay, so update. Done with the book. 7 out of. I mean, like I'm going to give it a 7 out of 10 because it's one of those kind of materials where you can kind of say, you know, there are some things that I will take out of this that I can apply in my life, I guess, but it's not like a I mean definitely it's not like a guide for you. I mean it's definitely not like the rule book that you need to use when trying to like navigate society. So I mean for those who don't know, like Revenge of the Tipping Point, at least in my understanding of the book, is a title that basically talks about how society moves and changes and how you can kind of like see these changes as a result, as a function of some kind of events, right, or some kind of behaviors in people. And the book does a lot of this social, should I call it social journalism? Is that the thing? Either way, the book does this kind of like sort of investigative journalism where it's not really investigative journalism. Either way, the book, the author like uses up certain instances in certain, say, like cities or towns or groups, and shows like how like one certain behavior defined, like exhibited by that group, affected XYZ event in society, right? So like I remember with the chapter on Poplar Grove where it talked about well, it was essentially like a community, small community that had a really, really bad self-unaliving like I don't want to say epidemic, no, I had like a self-unaliving epidemic, right? And you know, like it talked about several things, but like the big takeaway is that because like the people who lived in that community all had like a very, very, very similar herd mindset when it came to certain achievements in academics and in school activities and the lifestyle for kids, right? Because of that, it was easy for like this kind of epidemic to spread. Whereas if you were to go to like a certain community where not everyone is aspiring to send the kid to like XYZ college that everyone else is also trying to send a kid to, like you got less of these incidents, something like that. It's been a while. I read this book like a few months ago, like months ago, so I cannot exactly remember like the full details of it, but that's the gist. Anyway, why am I even talking about this? Let me see. Okay, so we're done with the book. 7 out of 10. Probably gonna revisit it again because I did take notes. Not super pragmatic theories seem to be derived from events with a lot more nuance. We're now reading template metaprogramming with C++. With C++ by Marius Benzilla, which is true. Matter of fact, I think I have like the book. Hold on, give me a second. Give me one second. I think like I have the book right here. low key, like, I haven't really, like, my goal, like, when I bought this book was like read this cover to cover, right? Why did I buy it? I don't even know. Like, honestly, I think I was influenced by Coding Jesus. I didn't even think he actually talked about it like specific book, but like he was like saying. I mean, I remember like there was a video of his that was basically saying like, you know, you got to read more books if you want to be a better programmer and stuff. And then like I picked up a couple of books. I have a bunch of programming books I need to start and finish. Hacker's Delight. I bought that book. I haven't even opened that shit, bro. I haven't even opened that stuff. Anyway, where are we? All right. So we're also reading the beam. Actually, no, that's not a title. Oh my God. Oh yes, it is the Beam book by the extended. Talking about the Beam again. All right. All right. Let me change this. I don't. Doing too much, bro. All right. Nice. Profile. Let's go. Has anyone even taken a look at this issue? Let's see. Wait, no. Wait, yeah, okay. Give me 1 second. Issues. Bro, no one is looking at this shit, bro. It's pissing me off. It's pissing me off. It's pissing me off. It's pissing me off because like at work, like we try to do this like auto docking. We try to like build like a script that does like auto docking for you, right? And then you get to visualize the docking simulations in Pymol. So like when installing Autodock Vina, was there Autodock Vina? I think yeah, Autodock Vina. You then has to like like install this like dependency package as well. The annoying thing is like if you use this specific like executable, like if you go to like, give me 1 second. So like where are the releases? So you go to releases, right? And then wait, what was this? May 26th. Okay, boom. They didn't put the asset, the code assets here. Well, the executable assets here. But anyway, you come here, you get the assets, bro. Like I installed this stuff, and then like literally all my user environment variables were gone, like gone, nada, nothing. Most annoying thing ever. Like, it's not true right now, but I was so mad when that happened. It's like no one cares. Like no one's gonna like they bro. That so many issues. Okay, refactoring. Let's look at these issues, bro. Okay, minus mine that I opened. Static build of blah 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 plugin. Let's see if OpenBabel plugins are built. Like I know nothing about the plugin system here, but whatever. If OpenBabel plugins are built statically, then this command results in this error. Built statically. What does that mean? So like you have all the files and leaking time. Wait, no. Static builds don't require DLL files. Is that a difference? Hold on. All right, the core difference is a static build extracts library code and copies it directly into your application binary at compile time. Whereas a dynamic build leaves the library code as separate files that are linked at runtime. Nice. Okay. Oh, well, I mean, we didn't care about this type anyway. Okay, cool. All right. So what they're basically saying is like, if your plugins are built statically in the sense that like the libraries that those plugins use have their code like inserted into the binary itself, so there's no need for like any of the library files at runtime. So if the plugin is built statically, then this command is often this error, meaning that like, let's see, so OpenBabel error in PNG format, PNG to format not found, probably the Cairo library is not loaded. Oh, so it's like, even if you statically, so like from what it sounds like, it seems that there is a dynamically linked library that is being dependent on anyway, regardless of how you build it, right? So and it's funny that it tells you -1 PNG files converted. I'm dying, bro. Even if this printed during the CMake configure step, checking for module Cairo, found Cairo. Okay, all right. So it does find the dynamic library, but it's kind of wild. I mean, like, unless maybe they're absolutely guaranteeing that like the PNG to format library is always going to be there. It's kind of wild that like you would need that. I mean, like, maybe I'm not obviously I'm not an expert on this, but this is just my opinion. It's kind of wild that they'll have you try to use like a dynamic library anyway when building statically. But let's see. Okay, so like it actually finds the module, right? It finds the location. All right, indicating that the CMake message is succeeding, and by default the Cairo library is actually being ignored when the plugins are being built in static mode. So it's misleading. It's not being loaded, right? But what could cause something to like be ignored in static builds versus dynamic builds? Because like, this is why like I should practice my C++ because I've actually never like tried to write code using dynamic libraries before. Because how does that even work? Like, how do you know which functions to call? Like, do you just get a header file and wait? So let me actually check. That has the okay, so you get the okay, because that makes sense, because they can't just expect you to like they can't just expect you to call like code from the binary. Oh, of course that makes sense. Of course that makes sense. So get a header file, compile time using it, as long as like the shape of the functions in the header file match the implementations given in the linked file. Yeah, cool. So like it's done to actually. Yeah, not dynamic allocation, no. Dynamic linking. I mean, does it really reduce the size of the well, yes it does. But like Oh, I guess it does solve that. I mean, if your issue is, I guess like if your issue is shipping the core application itself, or that the library files, and assuming like the DLLs are already existent on the users and on the users end, then I guess that makes sense. You have a smaller binary to ship, because at the end of the day, like if you want to make the claim that the program is smaller, I mean it's not really smaller, because like the program consists of all the files it needs and everything it needs, right? So like you still count the DLL even if it's like stored in some obscure directory. You're just like, all you're doing is just offloading like the calling of the functions. No, with the storage of the files that you need. Reduced memory footprint? How do you get a reduced memory footprint? Okay, well, so this user is saying that you get a reduced, wait, hold on. Bro, don't tell me that the mic picked it up. Alright, note that static libraries and therefore static linking are the more traditional approach. Okay, cool. Yeah. Shared libraries and dynamic linking were devised and became overwhelmingly popular for a few main reasons. So one, reduce storage size for applications relative to linking libraries statically, which makes sense because you're not including all the library contents you need. So like therefore less stuff to include, less stuff to compile, less executable size, and less storage size. You get that. Reduce the memory footprint though for applications relative. So reduce memory footprint for applications relative to linking library static. I think wait. So I think the reason for that is because first of all, like how like your program works, right? Like you have all your code and gosh, I've forgotten how this memory diagram works. I know you have your code, like your functions, and with your memory addresses and like the struct locate and the memory struct signatures and the memory addresses. They are stored in like they are out. So when you load a program, right, so for into memory, you know, you have your stack and your heap. So I think like beneath the stack, the data section stores your actual code, right? So I guess in that sense, like because your data, but wait. There's no way actually, right? Like because like if you, oh god, my mind is all over the place. So what I'm thinking is like, yes, like the reason they're talking about it having a reduced memory footprint could be the fact that like there's less code in the data section of your allocated like block of memory, right? But then it's also making me think. Like, are you telling me, for instance, like when Google Chrome like loads, like we load the entire like Chromium library into memory in the data section? Wait, that doesn't make sense. Okay. Well, okay. So like, I mean, I guess like, I guess like that, like if you were to think through my rationale, like it would kind of make sense that like the reason why there's a reduced memory footprint is because there's less code to put in the data section. It's the reason that dynamic language. I think that the programs that use shared libraries are usually slower than those that use that. I mean, yeah, like I guess that makes sense because like, gosh, let me stop guessing things that I get and having them make sense all the time. But like, because without all like, because thinking about it, right, like dynamically linked, right? If you're not going to load the libraries in, no. Well, I guess I'm making the assumption that like because it's dynamically linked, it means that we're not going to load the DLL into our code, into our data section. Let me check that assumption before I move on. So let's see. The OS, so when an operating system maps a DLL like or a shared object into a process, it manages memory sections through a highly structured architecture. So like that alone could introduce some overhead, which coming to like the wait, what was the IBM summary? There was a summary. There was a which already kind of gives you an intuition as to why this is the case, right? Like programs that use shared libraries are usually slower than those that use statically linked libraries. So well, the text, oh, it's not even a data segment, it's a text segment. All right, okay, cool. The OS memory manager maps the DLL into its own independent region of the process's virtual address space. It behaves like the main executable, parsed and separated into different functional segments based on its file headers, such as portable executable formats on Windows, right? The code, oh, it's a code segment, not a data segment. Oh my gosh, yes, my bad. It's the code segment. I kind of knew I was like mixing this up, right? But either way, the code segment, the DLL's actual executable code is loaded into its own read-only executable memory pages. Okay, I guess it makes sense. Like you don't want to mutate this anyway, right? It is never put into your own programs.data section, which lacks execution privileges. Okay. The data segment. So the data segment, the DLL has its own separate data section. Is this read only? I mean, oh, wait. Actually, no, it can't. No, that was such a dumb question. No. Because you do need to mutate stuff, right? Yeah, you do need to mutate stuff. And there's no point if it's not mutable. While the executable code pages are shared, the OS creates a private, isolated copy of the DLL's data segment for specific processes. This prevents different applications from using the same DLL from overriding each other's variables. Nice. Execution prevention, DEP/W. Jesus Christ, do I know that? Caret? X. Modern CPU architecture enforces a rule. Memory is either writable or executable, but never both. Huh. Your program's data section is writable, but never executable. If the OS tries to run code stored in the data section, it will trigger a critical seg fault or access violation crash to block malicious exploits like buffer overflows. So basically, in a so what is a virtual address space? Is a virtual. What's a virtual address space? A virtual address space is an isolated contiguous range of memory addresses that the operating system provides to a running process. I need this. Let's go here. All right, come here. A virtual address space in operating systems. In the operating system, virtual memory plays a very vital role in managing the memory allotted to different processes and efficiently isolating the different memory addresses. Okay. The role of the virtual address is to assign a space to the ledger of all the virtual memory areas that are provided to different processes. Okay, whoa, let's unpack that. Right?